There might be a
Alright, first of all, we're going to factor. I took out a negative first because, for me personally, I like factoring when whatever's in front of my x squared is positive. I find that a little bit easier. I need to get 5 here to get a 2 at the end. If I put a 2 on the outside and a 1 on the inside, my outside would be 4, my inside would be 1. That makes 5. Let's just check. I need a negative 5, so I need negative 4 and negative 1. I double check when I multiply this out. It gives me the minus 5x. It gives me the plus 2. This does factor correctly. My non-permissible value, x can't equal 1. Does it cancel out? No. Since it doesn't cancel out, we have a vertical asymptote at x equals 1. Now, do we have horizontal asymptotes? No. This is the situation where the degree is bigger in your numerator, and when the degree is bigger in your numerator, you never have horizontal asymptotes. It didn't cancel out with a whole, so this is the example where we have an oblique asymptote. We're going to have a diagonal asymptote at y equals, and we have to figure out what that is. So as far as figuring out what that is, this is where we use synthetic division. Our original equation was negative 2 x squared plus 5x minus 2. We're dividing by x minus 1, so you put a plus 1 out in front. Bring down the minus 2, multiply and add, multiply and add. The negative 1 is your remainder. And you can ignore your remainder. It's going to just be negative 2x plus 3 as your oblique asymptote. Again, once I've got my asymptotes, I start with my graph. I'm going to have a vertical asymptote at x equals 1. And my oblique asymptote at negative 2x plus 3, that means I have a y-intercept of 3. A slope of negative 2, go down 2 over 1, down 2 over 1. Oh, thank you. It's going to be plus 1. I mean, I'd still lose a half a mark, even though you get to ignore the remainder. So making that mistake makes no difference to the whole question, but on the exam, they would still notice that mistake and they would still deduct me a half a mark for an adding mistake. Thanks for noticing. I did negative 2 plus 3 and I wrote negative 1. Because I already, see again, my brain was like, oh, you can just ignore the remainder. So my brain took a break, and then I made a mistake. Okay. So we got our asymptote. Well, next, y-intercept is always the easiest to find. I'd go to my original equation and plug in zeros for all of the x's. Can you see in your numerator you get minus 2? In your denominator you have minus 1. Minus 2 divided by minus 1 is 0, 2. Next, my x-intercept. Plug in 0 for y. I would go to my factor form that I had 2x minus 1 minus 2 all over x minus 1. And again, when solving for an x-intercept, you're only looking where is that fraction equal to 0, and a fraction is only equal to 0 when its numerator is equal to 0. So we're going to get two x-intercepts, one at positive 1/2, comma 0. That would make that first factor 0. And the second factor 0 is when x is 2. So I'm going to label those points on my graph. 2 comma 0 and 1/2 comma 0. Now we're going to check our sections, whether or not we have enough points to draw our graph. Section 1 is here. And remember that oblique asymptotes don't make new sections. So sometimes students think, oh, there's a section 2 and a section 3. There's not. There's only one more section. It's section 2. Because there's only one vertical asymptote. The x equals 1 breaks it up into 2 sections. The oblique asymptote doesn't break it up into sections. Even though you're like, oh, I kind of want to do a section 2 and a section 3. In section 1, do we have points? Yes. Do we have enough to draw our graph? Absolutely. It's going to go towards those asymptotes and look like that. Each of our x-intercepts has a multiplicity of 1, so we know that it has to go straight through. Section 2. You have enough to draw section 2 already. Has to go towards the asymptotes. And you already have an x-intercept that has a multiplicity of 1. We don't have to do any more nice points. This graph is done. Sometimes in these ones you feel like, oh, it shouldn't be done already. It feels like I should do more work. Circle question number 5.